Hello, welcome to LangGraph, one of the best tools for boosting productivity of both software engineers and their teams. Let's get started. So, what is LangGraph in general? LangGraph is an open source AI agent building framework created by LangChain, and it offers high flexibility and enables developers to connect large language models, LLMs, in ways that allow the LLM to control subsequent actions. So basically, we give the ability to the LLM that is connected to choose what should be done next based on the context and based on what was done before, based on a prompt, and to make the best solution possible. This framework is supported by two major languages. It's JavaScript and Python, and it was released back in October 2024 and has been steadily growing in popularity ever since, offering an alternative to the competitors such as crew.ai and Microsoft's Autogen. What is the value proposition of LangGraph itself? So what it makes it so particularly useful? First of all, it supports streaming out of the box with both tokens and messages. Second, it supports multiple executions at the same time, or so-called async execution. Next, third one is that it's persistence with database, so you don't need to persist your state between invocations. Next, fourth is support of fault-tolerant tool calls. That means it can handle any failures with external APIs. Fifth, it also supports human in-loop execution. And sixth, last but certainly not least, is that because of the way it handles state, it makes it quite easy to decide what the next action should be. Moving on, now let's talk about core building blocks of the LangGraph. So we have the nodes that actually have the code that should be executed. Different nodes can be connected with each one using the edges. And also we have the conditional edges, which can decide on what happened so far and based on the context, what the best next solution should be. Should we run node 2 or node 3? And it will automatically on itself will decide what should be better executed. And all of these are actually tied together with the state which stores, with this graph state, which stores our inputs, outputs, and variables. So they could be passed between nodes. So that basically means that they can be accessible everywhere. And that actually lets us make the interaction between nodes altogether way more effective. Moving on, let's talk a bit about the architectures. So there are three main architectures that are supported. First one is router. So it actually, we have the conditional edge, which chooses which prompt should be executed based on the input to the graph. Next, we have the React agent. So here the language model can decide which tools should be executed, and we can execute these tools as code locally, and the responses can be passed back into the language model for it to decide the next steps. And last but certainly not least, the reflection agent. This is in this kind of architecture, we have two language models, one of which is actually generating the output, and another one is reviewing that output and identifying any mistakes that could be there. And if it actually finds the mistake, it passes back the feedback to the first language model. And so the first language model will be able to correct them. Without any further ado, let's jump into the example and see how it can be useful in practice. So here we are. Let's see firstly what the script we have. We have a small script called testscript.py. We have two variables here. First one is x equals 2, so it's basically an integer, and the second one y equals test, so that's a string variable. And what we're trying to do here, we're trying to add x and y, and we're trying to print the result in the terminal. And let's actually try doing it. So when we try to do it, you will see that we get the error, unsupported operand type for plus, integer, and string. So basically, what we see here as an output is that we cannot add string and integer altogether. And this is why we have created this beautiful Jupyter notebook showing how we can actually fix it using our LangGraph. So let's go through all the files to see how it can be useful and what we can do with all that stuff. So first of all, we have two functions. One that will actually let us read code from file, and the second one is that will actually help us write code to the file. Moving on, we have here the utility inside of a LangChain called PythonREPL. We can actually, and what we will do, we will instantiate it. And this tool is able to execute code. So as you can see here, if everything is okay, we will see the result of code execution. And if not, we will basically see fail to execute and we will see the error. Very specific thing here is that if, for example, we will run this cell, we will do it later. When we will run it, you will see that you won't see that problem. Like we won't see like fail to execute and see this kind of error, because we will actually see result code execution. We will see this because this part of the code is only responsible. So like we will see the fail to execute only in case if this function won't be able to read the code and to try to execute it. So it's not about the script, it's about the this tool to be able to actually run the code. Next one, we need to create instance of ChatGPT that is able to do the tool calling. We bind the tool, and this model is capable of running PythonREPL tool. Then, as you can see here, we will open the test script. Like in case if we don't see it, we will see an error. And here you can see the content, the prompt that we're actually sending to the LangGraph. So basically what you can see here is that we have a task to execute the code, and what we will do is that we will ask to return false if code produced an error, and if it worked, we will just return true. So in the end, we will see that like we will do as much iterations as possible until we see the true. So like when we see false, we will go through the iterations until we reach the max iterations or until we get true back to us. Then we will also jump through to see how the actual message that we're sending looks like, how it will be seen by the model. And here we will, at this point, we will make a call to the tool. And next, we will work with agent. So here is the structure of that agent. You can see the message, you can see the error, whether it's Boolean, so it can be true, false. Error message is a string, so we will see a whole error message that we're getting back. We will have the file path, we will have the code itself, and the number of iterations. Next, let's go through all other functions that we will use here. So first of all, we need to identify the file path. We then need to be able to execute code with model, of course, and to be able to rewrite code as well. And of course, be able to go from one step to the another, because we'll have like the iterations. Here, as you can see, we will have maximum of 3 iterations. So if, for example, model won't be able to fix the code in 3 iterations, we will just, agent will exit. So it will it will save us from having like the infinite loop. And next here you can see the actual LangGraph usage. So we will have 3 nodes. First one is to identify the file path. Second one is to execute code with model. And third is to rewrite the code. So first of all, we're setting our entry point. So this is the first node that would be actually executed. This is identify file path, because if we don't have a file path, so we don't have the file, there's no way to execute code or rewrite it, because we just simply don't have it. So this is very, very important entry point. Next, we're adding the edge between identifying file path and executing code. So as soon as we identify the file path, second, what we do is we're actually executing code with a model. And we're also adding here the conditional edge, execute code with model, And if we're getting error, we will rewrite the code, and we will end if we get the OK response or if we reach max iterations. And yeah, we're also adding edge between rewriting code and executing code with model here. Then we will compile everything. Down here, after I will launch everything, I will also show you how our architecture looks like. And after that, we will invoke everything. So yeah, let's get started. So first of all, doing to our first functions, just identifying them. Next, instantiating PythonREPL here. Moving on, instantiating ChatGPT. Now given the message and etc. like this. Yeah, it takes a bit more time, so we can see everything is stored here. And let's see how the message looks like. So yeah, as you can see here, we can see the like execute the following code. It will see the code that should be executed. And yeah, like moving on, it's like it's pretty long. We can see the token, so we can see all the internal information of how it will work. Moving on, let's now connect this tool. And as you can see here, we can see that PythonREPL can execute arbitrary code, use with caution, and result code execution, type error, unsupported operand, type 4+. Exactly what we get down here in the terminal. Now let's instantiate our agent, and yeah, let's start all our functions. It's all good. Now let's do our line graph, and here on the image you can see the architecture of our whole system itself. So we have the file path, execute code, and if an error, we will get back to the rewrite code, and we will get back trying to execute that code again as soon as much as possible, or when we reach OK or max iterations, we're just finishing the code itself. And now let's invoke the code. As you can see here, after the invocation, you will see that result code execution is type error, unsupported operand, types 4+. Evaluation results is that we still have like something is not okay, error in test script, one try is done. And here is the suggested code by our code graph itself. So x should be 2, y is equal test, and we're now printing the string x plus y. So we're basically converting our x to the string. And yeah, in that case, it will all work because we can actually do the execution like this. And as you can see here, we have the result. So we got like 2 iterations, as you can see here. And yeah, our AI agent was able to help us fixing everything. And yeah, so like it has reached the end before reaching max iterations because it saw that code is now executable and it all works. So this is very basic example of what could be done. Something that you can see by yourself, something very simple, something very plain, but it shows how much potential it has. And imagine it like scaling to the work of a whole team, helping it write you any like test functions, helping you to fix the code, and etc. And what is very cool about all that LangGraph framework is that it can be automated. So you can make like the big automations for whole your team or for yourself that will actually help you be way more productive and give like the output, give the way bigger results than before. It just actually at this point is limited to your imagination. So yeah, hopefully that was very useful for you. Thank you for your attention. And if you will have any questions, I would definitely love to answer them. And yeah, have a nice day. Take care.